Let theta naught be the value of an initial angle where theta naught is strictly bigger than 0. Let's say that theta naught is 10 degrees, the initial angle. We increase the angle by 5% each time. What is the value of the angle after 10 iterations? First of all, we need to derive the formula. So theta 1 equals theta 0 plus p theta 0. It means that in the first iteration we have the angle theta 0 plus we increase it by some percentage p. And here is 1 plus p times theta 0. Second iteration, theta 2, theta 1 plus p theta 1, 1 plus p theta 1. Theta 1 is given by this formula here. So it's going to be 1 plus p theta 0, 1 plus p to the power of 2 theta 0. Theta 3 is theta 2 plus p theta 2. I can take common factor 1 plus p and I have times theta 2. Theta 2 is given by this expression here. So my theta 3 is 1 plus p to the third power times theta 0. By induction, theta n is going to be 1 plus p to the power of n times theta 0, where n is the number of iterations. So assume that you have theta 0 and then you increase the angle going counterclockwise. You want to find what is going to be the value of the angle after 10 iterations. My p is 5% here, so theta n is 1 plus p to the power of n theta 0, 1 plus 5% to the power of n times 10 degrees. So theta n is going to be 5%, so we write it as a decimal, 1 plus 0.05 to the power of n times 10. 1.05 to the nth power times 10 degrees. So if we want to find in 10 iterations what is going to be the angle, we plug in n equals 10. So that's approximately equal to 1.629 times 10 degrees. That's 16.29 degrees. So if you have an initial angle that is 10 degrees and you increase each time by 5%, then after you increase the angle going counterclockwise, then after 10 iterations the value of the angle is going to be 16.29 degrees. Also you can find what is theta n plus 1. Theta n plus 1 is going to be 1 plus p to the power of n plus 1 times theta 0. And if you take the ratio theta n plus 1 over theta n, you get the following. Theta 0 I can simplify because theta 0 is bigger than 0. That's my claim. So I can simplify the theta 0, and I have 1 plus p to the power of n. I can split this up by using the laws of indices. And then I can simplify this safely, because I have 1 plus p, which is strictly p is bigger than 0, so 1 plus p is bigger than 1 is bigger than 0. I can simplify this and I have 1 plus p. So theta n plus 1 over theta n equals 1 plus p. P is between 0 and 1, so this is gonna be bigger than 1. So what I have here, that theta n plus 1 over theta n is bigger than 1, strictly bigger than 1, so theta n strictly less than theta n plus 1, which means that the previous value is going to be less than the next increased value here. Usually we use this formula for interest rates, but you can use it also when you have this kind of problems where you have an initial amount you want to increase by some percent, and you want to find after some number of years or number of iterations what is the final value. Here I have implemented the formula, I have derived the formula. You have an angle theta naught, you go counterclockwise, you increase this each time by some percentage p, and you want to find what is the value after some number of iterations. So if n equals 10, as it's in the case here, after 10 iterations, and by increasing the angle by 5% each time, where the initial angle is 10 degrees, then theta after 10 iterations becomes 16.29 degrees.